Youngsaver here from the College Board. We're sticking with topic 2.5 today. In this video, we'll distinguish between correlation and causation. So what are we going to learn today? We're going to learn what the difference is between correlation and causation. How do we factor in alternative explanations into our data analyses? And we're going to learn about what kinds of inferences we can make from data that show strong correlations. Let's look at an example. And this is an example that we've been looking at for the last few videos. We've noticed that in the United States, nationally, high and middle income students tend to perform better on math exams than low income students on average. This is called the achievement gap. And if we zoom in on those gaps in this National Assessment of Education Progress data set, we can see those gaps have been consistent over multiple years. And an important note here, this data says nothing about individual performances. It's just merely a trend of averages among these groups. And this data says nothing about innate intelligence. Achievement on exams is very different than intelligence as we know it. So middle upper income students have wealth privilege, and often that means they don't face as many educational barriers as their lower income peers. So the question is, if we think of the United States as a place where schools equalize opportunities for students, can education systems actually enact that and equalize opportunities for lower income students attending schools? So one way that school leaders have thought about this is thinking about the attendance gap. Nationally, higher income areas tend to have fewer chronically absent students. There are possible reasons behind this. Maybe for higher income students, they have more readily available access to transit. Potentially they don't have to work as often to support their family as their lower income peers. There's a bevy of possible explanations for this. So what school administrators have thought is that, well, if poverty causes low attendance and then low attendance causes low test scores, if we have initiatives that fix attendance, then maybe we'll see higher test scores, and that will lead to a more equal opportunity for all students. So we're going to analyze really today, this is where we're going to really hit the nail on the head, is that statement, that idea, reasonable or BS, bad statistics? And based on our past videos, we've seen through a random sample of 11 students in Texas that it looks like, yes, attendance should help. It's pretty clear there's a positive, linear, very strong relationship between the percent of school days that students attend and their test scores on this math assessment at the end of the year. We've also noted that this trend is seen in data sets with thousands of students. So here's what school administrators did in the past several years. They piloted some large-scale programs such as calling chronically absent students, hiring attendance case managers and coordinators, even using rideshare apps for students with transportation issues. And sometimes these initiatives are quite expensive, but they did help attendance. Attendance rose in districts where they implemented such strategies. However, the point I left you with last time is that test scores stayed flat. And I asked you, how could that be possible? What happened? Well, this was one possible explanation that administrators and school leaders had in mind, is that poverty causes low attendance and low attendance causes low test scores. And if you fix the attendance, you fix the test scores. However, what if that is not the true chain of causality? What if instead poverty causes all these things? And we know they do. Poverty can cause students to feel hunger. Poverty causes students to live in neighborhoods where there's worse schools that are zoned to them. Poverty causes students to potentially have less study time because they have to work a job to support their family. They have to take care of family members because their parents are working 2 jobs. And so what if those variables are the true causes of low test scores because they limit the opportunity of students to fully engage in school? And so if we fix the attendance alone, we haven't addressed these other potential variables. And so the low test scores continue because of that true chain of causation. This is one alternative explanation that leads to what we've seen in the data. So this is one of the most fundamental concepts that is touched on here in our course. Correlation does not equal causation. Correlation does not equal causation. Just because attendance and test performance strongly correlate, it doesn't mean they have a direct causal relationship. There may be other variables, hunger, school quality, amount of study time students have, that actually have causal effects. And so high attendance may not be a strong cause in and of itself. Rather, high attendance may simply coincide with other variables that carry high causal advantage. This means that there's a correlation, but it doesn't mean that there's a direct causal relationship. So if it's not attendance, then we can think about how can we identify these true causal mechanisms. So I gave some potential ones we don't know in fact. How can we identify those true causal mechanisms that will help us fight educational inequity? Well, causal inference is coming soon. We're going to learn about how to infer causation once we get to Unit 3. Let's cover a couple other causation fallacies. So we talked about how sometimes there are other causal variables lurking in the background. That was in the last example. Other times, correlations might be completely coincidental. Here's a graph of the divorce rate in Maine over time and the per capita consumption of margarine, how much butter people eat per person. You see a very strong correlation. They coincide really well together. If you put it in terms of a scatter plot where each year is its own data point with using margarine as the explanatory variable and the divorce rate as the response, we can see a very strong positive correlation. But of course, that's coincidental. So what should we take away for today? Correlation does not equal causation. Beware of other variables or coincidental correlations. This is super important. And what I really want you to think about today and take away here is think about what you can do to investigate and ultimately fight educational inequity. This is a huge issue that our country faces. And as young statisticians, as young critical thinkers, as people who care about this issue, it's really important to rigorously investigate what's going on, what are the driving factors, and then how to fix them. And again, we're going to cover that in our next unit. But I really want you to think about what can you do to investigate and to make change. As always, when analyzing data, statisticians, be critical, be cautious, be compassionate, and avoid BS. That's it for today. Thank you.